In this video, we're going to be talking about the general structure of an atom. So let's not waste any of your time. Let's get right to it. Now, when we're talking structure of an atom, okay, first of all, we're talking about an atom, which is that basic building block of everything that has matter. If you want to think of something that maybe visually you can compare it to, you could think of a cell. Okay, a cell in a body. Cells are the smallest living thing of all things living. Cells make up tissue. Tissue makes up organs make up the organ system, and so on and so on. So they're that building block. Okay, atoms are the same thing when it comes to matter. And of course, the thing you have to think about is matter is what makes up cells and everything else. So they're all kind of interconnected. But when we think about the structure of an atom, okay, atoms have a nucleus, as you can see in the diagram. And it's that nucleus that holds the protons and neutrons. And that nucleus has some pretty large ramifications when it comes to science. If you've ever, I'm sure you've heard of the atomic bomb and how that ended World War II and everything, or at least our aspect of World War II. But it's that splitting of that nucleus to release all that power that was the foundation for the atomic bomb. Lots of energy and power in there. But for us, we're talking about the nucleus, which holds the protons and neutrons, and we'll talk about those individually. And on the outside of that nucleus, and kind of a little cloud on the shells, the energy levels, which we'll also talk about, are the electrons. Okay, in each of these subatomic particles, the protons, neutrons, and electrons, there's some information about them, and as you can see, it says there to add the tables. Add this table to your notes, but I am gonna talk about it. But protons and neutrons, they do have a mass. There is a little bit of weight to them, but it is so small you could not use a traditional unit. Ounces, pounds, grams, whatever. It would be such a small decimal number that it wouldn't be very usable in science documentation to use. So they essentially made up a unit small enough to describe, and so they simply took the protons and neutrons, and their mass is basically the same. So they just made a unit to refer to both of them, AMU, atomic mass unit. And that's the essence. A 1 is a reference to one proton or one neutron. So if you have an element that has one of each, a proton and a neutron, then their mass would be 2 AMUs. But again, really, really small. And electrons, they do have mass, okay, but it is so much smaller than protons and neutrons that it adds almost essentially nothing to the overall atom. So they get a 0. It'd almost be like if you were measuring elephants or weighing a pride of elephants, and you had all the elephants and all those weights. So we're talking thousands and thousands of pounds. But you also included, there were some peas laying on the ground, and you wanted to include those as well. The peas would add so little mass to the overall structure. If the elephants were the protons and neutrons and the peas were the electrons, they would add so little structure that you wouldn't even consider them as far as the weight. And it's the same thing with electrons. They're so much smaller in mass that they do not add anything. So they get a 0 for the mass, and those numbers is what makes up the atomic mass number, which we're going to talk about soon. But the other thing to consider is the charges, and they are super important when it comes to bonding, when it comes to knowing the overall energy level, electrical value of a molecule or a compound, And this is one of those aspects that if you've had a chemistry class, then you've had some reference to this. And if you haven't, you'll just have to make sure that you grasp the concept. But the idea of protons being a positive charge, P for proton, P for positive charge. So they get a plus sign as their symbol. And electrons are negatively charged. And that's why these two kind of group together. It's opposites attract, just like magnets with that north and south. You can, those will attach to each other and hold strong. Protons and electrons being oppositely charged. Electrons negative, positive protons, and that's what allows the bonds to occur. Neutrons, as you might example, neutron, neutral, have zero charge. They just sit in there. They kind of help balance everything out to some degree. But anyway, that is the information from this table. Be sure you grab that and add that to your notes. Okay, our next topic, as you can see, is the atomic number. And looking at the diagram, this is a diagram of a single square on the periodic table that has some of the information listed for you. Things like the element symbol, O for oxygen, the name, oxygen. But the two that we're going to consider on this screen and the next screen is the atomic number and the atomic mass. These are super, super important to grasp the concept of. And it's the idea of atomic number is the number of protons. Okay, and the way to identify that, obviously if you're looking at a periodic table, it won't have them labeled. It may have one example up in the corner somewhere. But the atomic number, the number of protons, it's also a whole number. Okay, so when you're looking at a periodic table, and if it doesn't have a table for you to identify parts, the one that is a whole number is the atomic number. It'll also be the smaller number. It's generally a close approximation of half because it's the number of protons, and so it's generally half. But it's a whole number. It's half of the other number, typically, somewhat. If the atom is balanced, meaning it hasn't gone through a bond yet, it's not part of a bond, then the number of electrons is the same as the number of protons. So if you look at the atomic number of a single atom or element that hasn't gone through, isn't part of a bond, then the atomic number will also identify the number of electrons. But it's usually at the top, I should say. I said usually. Sometimes it could be on the side. They could be side by side at some point in time. But in most traditional periodic tables, the atomic number is at the top. Okay, now the atomic mass number is the other number that we will consider. Again, looking at the same diagram, you can see the atomic mass number at the bottom. It is the number of protons and neutrons. We talked about the mass in an earlier screen. So the atomic mass, the number of protons and neutrons, the atomic numbers, number of protons, the atomic mass, the number of protons and neutrons. And it is a decimal number. And there's a reason for that. We may talk about it in class, but you'd have to actually take a chemistry class to fully get that concept. But it is a decimal number because it's an average. It's an average of all the isotopes, and we're not going to get into isotopes. So, but if you take a chemistry class, or just ask me in class if you truly want to know, we can. And this number is usually at the bottom of the square. And again, I say usually, as I already mentioned, they could be in other locations, but typically it is at the bottom. Okay, our next concept to consider is the discussion about the electrons. Okay, the electrons are super important in a chemistry setting. and really drive a lot of things that happen. When we talk photosynthesis and cellular respiration, we'll be talking about electrons. But it's the idea of electrons are the one aspect that can be changed or altered on an atom. You cannot change the number of protons. You cannot change the number of neutrons. They are inside the nucleus. Okay, that cannot happen. That never happens unless you do something super scientific like split an atom. But the electrons can be transferred or shared in variations of bonds. That changes the atom, and it also changes the identification of the atom, which we're going to talk about here. So if an atom loses or gains an electron in a bond, that's called an ion. And it can be a positive ion, it can be a negative ion. If it is a positive ion, then it means it has gained or it has lost an electron, and therefore has more protons than electrons, and more positives than negatives, and therefore it's a positive element or atom. If it gains an electron, then now it has more negative electrons than positive protons, and it's considered to be or called a negative ion, and its symbol, as you can see on the screen, would be Na negative, or if it lost an electron, then Na positive. Our next concept to consider is a reference to the shells. Okay, there are where the electrons are located are called shells. They surround the nucleus. There are 7, but these are energy fields. Okay, you cannot see them with the naked eye, no matter how much magnification you try. Okay, they're just like sun rays. Okay, they're there, but they are not seeable. You can only see them if there are electrons on them, and you really can never see the shells. You can just see the shape of the shells because the electrons. You can see the electrons. It'd be just like if you were in a helicopter and roads were invisible to the naked eye, but you could see the cars, and so you could tell where roads were based on cars. So if you were in a helicopter and you were looking down on Highway 49 or Austin Street or Ash or Hickory or whatever, and the roads were invisible, but you could see the cars, you could tell where the shells were based on the cars. There's a total of 7, and the atoms only use the ones that are needed to house the amount of electrons they have. That's a concept called electron configuration, which is a fun topic, a very laborious, tedious process of positioning the electrons in the proper place. And again, a chemistry class will do that ad nauseum. We will not. It is a lot of fun. I enjoy it. But anyway, it's not a topic that we are going to get into, but we just want to know there are 7, and the electrons are on them, placed in a particular pattern, and the rest are simply not active if they are not being used. Well, that's our show for this video. The next time we get together, the next one you watch, will be about the general properties of a bond. So with that, we will say goodbye.